With the rapid development of new services such as WLAN, network monitoring and video calling, numerous wireless APs, IP cameras and IP phones keep emerging in our daily lives. Generally, a large number of IP-based clients must be installed at special positions where power sources are unavailable nearby. The installation requires lots of labor and materials due to complex network cabling and power cabling. The Power over Ethernet technology enables a device to not only transmit data for IP-based clients, such as APs, IP cameras, and IP phones, but also supply power to them at the same time. This eliminates the need to deploy a power supply system for every IP-based client, thus greatly saving on labor and materials. TEF1118P and TEF1126P are PoE switches specially designed for wireless and monitoring projects. TEF1118P and TEF1126P respectively provide 16 and 24 megabit PoE ports and a maximum PoE power output of 135 watts and 225 watts. They both have a 1 gigabit electric uplink port and a 1 gigabit optical uplink port. All the ports are under 6 kilovolt lightning protection. These switches help reduce deployment difficulties and cabling costs of APs and cameras. Why is 6 kilovolt lightning protection a must for a dedicated monitoring switch? For video surveillance, lightning strikes are a major cause of product damage. Once a video surveillance network experiences lightning strike, some PoE switches of the network may be damaged, or worse, the entire network may fail. Losses to customers are beyond measure if devices are damaged by lightning strikes. Therefore, we apply 6 kilovolt lightning protection to both the ports and power modules of these two switches to protect them against thunder and lightning. Why is the maximum PoE power output of these two products less than the maximum per port output of 15.4 watts? The TEF11 series is mainly designed for connecting low power clients, such as APs that offer a bandwidth of 300 megabits per second or less, and cameras that consume 200 watts of power or less. Usually, each of these clients can work properly with a 6 watt or 7 watt power supply. Therefore, we set the maximum power output of 16 PoE ports to 135 watts, and that of 24 PoE ports to 225 watts. What are the purposes of the 4 modes available on the front switch panel? The 4 modes are designed for 4 different scenarios. The first, CCTV. Port 1 to port 8 support QoS, ensuring that important voice and video data is transmitted with top priority. The cache of the gigabit uplink ports is optimized as well. If the switch is connected to several IP cameras, this mode is recommended to ensure smooth video playback. The second, standard. All ports can communicate with each other. In this mode, the switch can be used as an ordinary unmanaged PoE switch. Third, VLAN. Port 1 to port 16 are separated from each other, and port 1 to port 24 are also separated from each other, but all of them can communicate with the gigabit electrical or optical uplink port. If many APs are connected to the switch, this mode is recommended to isolate DHCP broadcasts and reduce broadcast storms. Fourth, extend. Port 1 to port 8 slow down to 10 megabits per second and implement auto-negotiation, but they can transmit data as far as 250 meters. This mode is recommended if a cable longer than 100 meters is used to connect the switch to a client.